We got sine inverse of 1/2. Who has it? I need an answer. I need an answer quick. Yeah, cool. 30 degrees or... Oh, not 30 degrees. You said 300. Yeah, 330 degrees. Or 11 pi over 6 or negative pi over 6. Yeah, this one says in degrees and radians. I'll accept radians. On your homework, if you forgot to put degrees and radians, I'm okay as long as you put radians. That's the most important one, I think. All right, I need arctangent of square root of 3. I need to know where is tangent square root of 3. You got it, Pablo? Pi over 3? All right, our last one is arccotangent of square root of 3. Arccotangent of square root of 3. Who's got that one? Need an answer. Oh, yeah. Pi over 6. Thank you, Alex. Pi over 6, says Alex. Do we agree it's pi over 6?
Yeah, for sure.
Oh, okay. All right. I was just asking. Jeez. You don't have to yell at me. It was just a question. All right. Next one is cosecant pi over 3. I'm going to... What was that?
Why is pi over 6?
I don't know.
I think it's pi over 3.
Ooh, we have an argument.
I disagree.
So we have pi over 6 or pi over 3. Let's check. Let's check. So we're doing arccotangent. So we have two possibilities. We're doing arccotangent, which means I'm finding the tan inverse of 1 over square root of 3, correct? Well, 1 over square root of 3 isn't on my unit circle, so I would just multiply bottom and top by square root of 3.
Makes sense now.
No, you brought it up. We have to do it. Oh, come on. Come on. It's square root of 3 over 3. And Logan already realizes what happened. Square root of 3 over 3 is pi over 6. You went to just the straight square root of 3, right? Yep. So it should be pi over 3 or pi over 6? I already forgot. Pi over 6. All right. We're all good on that one then? I always ask questions. It never hurts to go through it because then you remember on the test, you're like, remember that one time I asked that question in class and Mr. Paving went through the whole problem and I knew the answer? Well, now I know not to do that mistake. All right. So we got cosecant of pi over 3. I'm going to go through this one. So I'm really looking for the inverse of sine of pi over 3. In other words, 1 over sine of pi over 3. In other words, I'm going to go to pi over 3, find my sine value, and I'm just going to go bloop. Right, just a little bloop action. All right, so I go to my unit circle. I find pi over 3. My sine value is square root of 3 over 2, so the reciprocal would be 2 over square root of 3. I need to simplify that, so I'd multiply the bottom and top by square root of 3. So my 100% correct answer would be 2 square root of 3 over 3. All right, now knowing how to do this, who thinks they have secant of 5 pi over 4? William.
No. I think I got it wrong.
Yeah, Nate.
Square root of 2?
Square root of 2?
Yeah.
Close.
Negative square root of 2.
Negative square root of 2.
I got it right.
Negative square root
I
of
just
2.
didn't show my work, so I had no clue what I was doing.
It's negative square root of 2, and let's go through that one real quick. So that'd be 1 over, secant is cosine of 5 pi over 4. I go to my unit circle and find 5 pi over 4. 5 pi over 4 is going to be in the third quadrant because my numerator is 1 bigger than my denominator. My cosine there is negative square root of 2 over 2. So we take the reciprocal of that, and I have negative 2 over square root of 2. That's a 3. That's a 2 now. Multiply the bottom and top by square root of 2. And that will actually result in negative square root of 2. Whew. Cotangent of pi over 2. The biggie. Because we kind of have to go through. Robbie. Really? But I have to go through 1 over tangent
No.
of pi over 2,
No.
which means it's undefined.
No. That's the
It's the reciprocal of undefined, right? And the reciprocal of undefined is 0. So what's actually happening here, if you want to actually see the math behind it, it's 1 over 0 over 1, which equals 1 over 0, which does equal 0. You bet your bottom dollar that's going to be on the test. All right, that will be on the test, where I ask like the cotangent of pi over 2, because it's the one where you can't just look up there and flip it. Because if you just flip undefined, it looks like it's just an upside down undefined, because it's a word, right? Anyone get that? Just me?
My bottom dollar is a Croatian bill in my wallet.
Well, thank you for announcing
Definitely
that.
did that.
I was very worried about what your bottom dollar was. Now I can sleep okay tonight. Whew. Lesson. I gave you plenty of time to raise your hand, didn't I? All right, Lizzie.
73.
Okay, 73. 73 says the tangent of arctangent of 1. So we're going to do the inside part first. We're going to find the arctangent of 1. So that means we're going to go to our unit circle and figure out where our tangent equals 1. Well, tangent equals 1 here, and tangent equals 1 here. So I'm going to put both of those angles down as my answer. Right now, I'm going to put both.
What are you doing?
But I'm going to put, it's both of them, right?
No.
No. Oh. Which one do I just randomly pick one? Just flip a coin?
No.
It's got to be on, yeah, we do our cotangent thing. So that means I have to use quadrant 1 or quadrant 4. Well, arctan is, where is 1? Well, that's at pi over 4. So arctangent equals 1 over, what did I just say? Why did I just lose myself in thought process? I think I was going straight to the answer. But it's going to be pi over 4. So we're just going to find the tangent of pi over 4. Well, the tangent of pi over 4 is just 1. It just brings us back to the value of 1. Does that make sense, Lizzie?
Yeah.
Cool. Cool. So it's almost like tangent, arc, cotangent canceled each other out. Yeah, Papa.
69.
Number 69. I just want to talk about this one really, really quick. Because 69 is going to be pretty much the same thing. These will just can't, and we're just left with pi over 6. But that's not going to happen here. Our cosine, actually let me just do this one. So here our tangent, arc, cotangent, or arctangent cancel each other out, and we're left with 1. We can't do that here. And we can't do that here because we're dealing with the angle 3 pi over 4. And 3 pi over 4 does not live in my sine inverses world, because sine inverse is down here. 3 pi over 4 is here. So we can't just simply say that these will cancel out, because they won't exactly cancel out. So we'd have to do each step. So the first thing I'm going to do is find the sine of 3 pi over 4. 3 pi over 4, the sine is square root of 2 over 2. So this is going to be square root of 2 over 2. Then we find the arcsine or sine inverse of square root of 2 over 2. But that's going to bring us to a brand new angle. It's going to bring us to pi over 4. So this answer is pi over 4. And it's crucial that we look through these problems and do them step by step, because it would have been very easy to say, well, these cancel each other out, I'm left with 3 pi over 4. But somewhere in your brain you should have been like, wait a minute, this is the wrong quadrant. So you had to do it step by step. So do all these step by step. Yes?
65.
65. I think 69 was the next one, Robbie? Did you ask 60?
I did.
Oh, who asked 69?
Sorry.
Okay. So 69, we're doing the tan inverse of cotangent pi over 6. So that's going to be cotangent of, and cotangent of pi over 6 is our tangent value at pi over 6, just the reciprocal. So we go to pi over 6. My tangent value is square root of 3 over 3, so the reciprocal is going to be 3 over square root of 3. So it's going to be 3 over square root of 3, multiply the top and bottom by square root of 3. And that's just going to turn out to be cotangent of, that'll be 3 over 3, it'll be just square root of 3. Well, that's going to be the same thing as arc, or our tan inverse of 1 over square root of 3. Once again, we have to multiply square root of 3, square root of 3, and we're looking for the tan inverse of square root of 3 over 3. Once again, you could go to your unit circle, or you should already know your answer. But that's going to be pi over 6 again. Does that make sense? Yeah, okay. Do you have a specific question on 65? Because I feel like that's the same.
I got to like, so cosine, well, arc cosine equals sine of 1 over x, right? So doesn't arc cosine of 1/2 equals sine, well, inverse of sine of 1 over 1/2?
Where does sine come from?
Wait, what?
We're doing the inverse of
I'm
cosine
stupid.
1/2.
No,
So we
no,
find, yeah, I don't know where you
never
threw
mind,
sine
never
all of a sudden in there.
I read it as secant. Or
Oh,
I read it as
okay, I got you,
cosecant.
I got what you're doing. Yeah, it's cosine. You threw me for a loop there. I was just like, what? All right, other questions? Yeah, Sam.
Number 39.
Yeah, 39. Particular question?
I don't know. I did it and I did it like a bunch of times and I'm just still getting the wrong answers.
Okay, so arc secant is going to be the same thing as cosine inverse, and it has to be 1 over -2. So we just got to find -1/2. Oh, this one's wrong in the answer guide. I posted on the, I put an announcement on there. This is wrong in the answer guide. So you have the right answer. Yeah, if you ever do a problem like this and it's wrong, just be like, it's got to be right, and just circle it. Don't try it 50 times and get the same answer, because it's not that many steps, right?
That's cruel.
What's cruel?
Putting it wrong in the answer guide.
I put a note on Google Classroom. That's about all I can do. All right. So let's go into trig functions. We gotta go a little quick. All right, trig functions are going to boil down to just that SOHCAHTOA. That sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then when you get to your cosecant, secant, and cotangent, you just take the reciprocal of those values. All right? So that means cosecant would be hypotenuse over opposite, secant will be hypotenuse over adjacent, cotangent will be adjacent over opposite. The other way we can write cosecant, secant, and cotangent, we can just write them as 1 over sine, 1 over cosine, and 1 over tangent. All right. Most of this should be a review from geometry, just rehashing this information. We're going to go ahead and do example 2. We're going to jump down to example 2. So 2 gives us the cosine theta value. It says cosine theta equals 4 over 7. And then it wants the rest of the remaining trig functions. So that means I need to know the hypotenuse, I need to know the adjacent side, and I need to know the opposite side to get the rest of the values. Well, cosine, SOHCAHTOA, is adjacent over hypotenuse. So we in fact know our adjacent side and we know our hypotenuse. So now we just have to know where to put those on our unit circle. Or not our unit circle, but on our triangle. So note this is theta. This angle here is theta. Opposite would be the one directly across from it. I don't know that value because I just know adjacent and hypotenuse. Adjacent is the one connected to the angle. So this length right here is going to be 4. So I always think of adjacent as you can kind of just draw an arrow down to it. So our adjacent is going to be 4. Our hypotenuse is going to be 7, and I'm missing this side length. To get to that side length, we have to use the Pythagorean theorem. The a squared plus b squared equals c squared. Well, I'm going to so we're doing a Pythagorean theorem, which is a squared plus b squared equals c squared. C is always going to be our hypotenuse, and a and b will always be our sides. So it's side squared plus side squared equals hypotenuse squared. Well, one of my sides is 4, so we'll have 4 squared plus b squared equals, instead of c squared, we're going to put 7 squared. So that's going to be 16 plus b squared equals 49. Subtract 16 from both sides, we have b squared equals 33. Take the square root of both sides, and we'll have b equals the square root of 33. I cannot simplify the square root of 33. There is no perfect square that goes into it. You can check. Our perfect squares are 4, 9, 16. That'd be the only one that could possibly go into it, and none of those do. So that means this side, in other words, our opposite is the square root of 33. Now what we have to do is fill in. We just have 3 values, and we just need to know where each of these go into these given things. So sine, SOHCAHTOA. So means opposite over hypotenuse. Our opposite is the one straight across, so that's square root of 33. Over our hypotenuse is 7. So that's square root of 33 over 7. Cosecant is just the reciprocal of it. So that's going to be 7 over square root of 33. That is not simplified. I need to multiply the top and bottom by square root of 33. So the simplified version is going to be 7 times square root of 33 over 33. Secant's the reciprocal of cosine, so that's just going to be 7 over 4. Finally, tangent, TOA. It's opposite over adjacent. Our opposite side is square root of 33. And our adjacent is going to be 4. That means cotangent is going to be our reciprocal, so that's 4 over square root of 33. Multiply the top and bottom by square root of 33, and in fact we have 4 times the square root of 33 over 33. Can't simplify it any further, and we have our answer. I want you to do the one right above it. All right, here's the values I got. I got sine equals 3 over 5. Cosecant was 5 over 3. Cosine is 4 over 5. Secant is 5 over 4. Tangent is 3 over 4. And cotangent is 4 over 3. Any questions on those? The bulk of this unit is just going back to this idea, that you know what sine, cosine, and tangent equal. All right, the only thing we're going to add to it is this one. Now we're given a point. We're given the point 4, -2. And it says use that point to create a right triangle and come up with your 6 trig functions. So the first thing I'm going to do is I'm going to plot that point. I'm going to go ahead and plot 4, -2. So I'll count it 4, 1, 2, 3, 4, and I'll go down 2, 1, 2, and I'll plot that point. So this is the point 4, -2. We could possibly create 2 triangles. We could do one over here, or we could do one straight here. We will always go to the x-axis. All right, we'll always connect this point to the x-axis. So if I have the point 4, -2, we're going to go straight up and connect it to the x-axis. Oop. And in fact, we'll always go to the x-axis. So if I plotted a point right up here, we would create this triangle. If I had a point way over here, I would create this triangle. And finally, if I was down here, I would connect the x-axis and create that triangle. So we're always going to connect that point to the x-axis. Well, that creates a triangle that this side is actually 4 units. That side is actually 4 units. And this side right here is negative 2 down. So that right there is negative 2. So the only thing we need to find is our hypotenuse.
Wait, won't that just be 2?
What was that?
Won't that just be 2?
Could be. Let's pretend like we just don't know. Wait, what?
Doesn't that have to be 2?
Why does it have to be 2?
Because it's like a length.
Oh, does it have to be a positive 2?
Yeah.
No, we're just going to use negative 2 on it. We're going to go ahead and use negative 2 on it. Because we have to use the values they gave us. All right, if we make it positive 2, that means we're putting everything in quadrant 1. But we have 4 other quadrants we'd make. All right, does that make sense?
Yeah.
So I get it's the length, but we put it on the xy plane, so we have to account for it being negative. All right, so we're going to do negative 2 squared plus 4 squared. I should have put that inside. Is going to equal c squared. Well, that's 4 squared, or 4 plus 16 is going to be 20. So c squared is going to equal 20. We're going to take the square root of both sides. That'll give me c equals the square root of 20. 4 goes into 20, so I can reduce that down to square root of 4 times square root of 5, which just equals 2 square root of 5. So our hypotenuse will always be positive. I fully understand that this should be positive or negative, but we're just going to take the positive for hypotenuse. Our legs can be negative, but our hypotenuse will always be a positive. All right, so now we just need to list all of our values. So sine theta, that's going to be opposite over hypotenuse, that's negative 2 over 2 square root of 5. Our 2's will cancel out, we'll have negative 1 over square root of 5. Multiply top and bottom by square root of 5, and we're going to have negative square root of 5 over 5.
Wait, how did you know which angle you're talking about?
It's always going to be this one here. Always going to be the one formed by the x-axis, kind of like just always the ones that we used for our when we were on the unit circle. So it's always going to be the one formed here. Right, guys? Theta will always be right here. All right, so we have sine. Now let's go ahead and find cosecant. Cosecant theta is just a reciprocal of sine. We can pick any one of these 3 values to take the reciprocal of. I'm just going to go ahead and take the negative 1 over square root of 5 and just realize it's just negative square root of 5. Cosine theta is going to be adjacent over hypotenuse. Adjacent must be that 4 because it's attached to that angle. So it's 4 over 2 square root of 5. 4 divided by 2 will give me 2 over square root of 5. Multiply our top and bottom by square root of 5, and we'll have 2 square root of 5 over 5. Our secant value is just the reciprocal. Once again, I take the reciprocal of any one of those values. The easiest one would be that 2 over square root of 5 to give me square root of 5 over 2. Because if I took any of the other ones, I'd have to simplify stuff. But you could definitely take this one, take the reciprocal, and then simplify, and you come up with the same answer. All right, tangent of theta. That guy is going to be opposite over adjacent. Our opposite was negative 2. Our adjacent was 4. So that's just going to be negative 1/2. Cotangent of theta is the reciprocal. So that's negative 2 over 1, which just equals negative 2. I want you to go ahead and do the next one. We're going to go ahead and do the next one. I'm going to show a picture of it, my answer. But don't look up unless you seriously have a question or you're done. So I got sine equaled 4 over 5, which meant cosecant was 5 over 4. I got cosine was negative 3 over 5. Secant is negative 5 over 3. And tangent is negative 4 over 3. So cotangent is negative 3 over 4. Okay. So we did that one. Now we're supposed to find the value of x and round to the nearest tenth. Round to the nearest tenth should tell you I got to pull out my calculator, right? I see a lot of you already have it out. All right, so find the value of x round to the nearest tenth. So x is a side. They give me an angle, and they give me the hypotenuse. So the bits of information that I need is x was my adjacent side. Once again, opposite would be the one directly across. Adjacent is the one that's just like bloop down. And I know my hypotenuse is 18. So I need to have the trig that actually stands for adjacent and has hypotenuse in it. Well, sine is opposite over hypotenuse, so that's not going to be it. Cosine is adjacent over hypotenuse, so I know I'm using cosine of theta. And that's going to be whatever my adjacent value is over my hypotenuse value. Well, now we're just going to plug in the values I know. I know theta is 42 degrees, so we'll plug in cosine of 42 degrees. My adjacent is actually x, and my hypotenuse is 18. So we have cosine of 42 degrees equals x over 18. Don't make this problem more complicated than it needs to. I've seen this done where people try to take the inverse of cosine to get 42 degrees out. Can you put cosine of 42 degrees in your calculator? Yeah, absolutely you can. So we're not going to do anything with this. We just need to get x by itself. In order to get x by itself, we need to multiply both sides by 18. So I'm going to go ahead and multiply this by 18. That'll cancel out my 18s, and we'll multiply this side by 18. And that's going to give me 18, let's put it in the other way. X equals 18 times cosine of 42 degrees. Since my angle is in degrees, my calculator better be in degrees. And you should come out to 13.4 degrees, because it does say round to the nearest tenth. Not degrees, I'm sorry, scratch that, just 13.4. Because that's a length, it's not a degree. Kind of like if I put inches there, then I'd put inches. Alright, so this one is figure out which trig you're using, what trig function you're using, and then plug in any information you can and use that to solve it. Alright, the next part is just inverses. We've already talked about inverses, so I'm going to jump right to the question. Do I have a better one? No. So anytime it says find the measure of an angle, as soon as it says find the measure of an angle, 90-some% of the time we're going to use trig inverses. Because inverse is the only one that pops out an angle as its answer. Alright, that was one of the things we learned when we were doing inverses. Is inverses always result in an angle. So if they're looking for the value of an angle, you should think, okay, inverses. Inverses result in angles. So I'm probably going to take an inverse down the road. But I'm looking at it and I have theta. I have an adjacent side. So 6 is my adjacent side, because it's right there. If it was opposite, once again, it'd be straight across, but it is not straight across, so it's my adjacent. And 9 is my hypotenuse. Once again, I'm going to go through my trig functions and figure which one has adjacent and hypotenuse in it. Turns out it's cosine again. And once again, I'm going to write down what cosine of theta equals. Well, cosine of theta equals adjacent over hypotenuse. I don't know theta. Up above I knew theta, so I could plug it in. I don't know it this time, so we're just going to say cosine theta equals, I do know the adjacent value, that's 6. And I do know the hypotenuse value, which is 9. Now in this case, I want the cosine gone. So I just want theta out. Remember, we cannot divide by cosine. That doesn't make sense because it's not a multiplication. The only thing we need to do is take inverses. All right, so I can take the cosine inverse of both sides to get rid of this cosine. So that's going to look like this. I'll take the cosine inverse of this side. So that's cosine inverse of cosine theta. And what I do to one side, I have to do to the other side, so I'm going to take the cosine inverse of the other side, which would be cosine inverse of 6 over 9, or you could reduce it to 2 over 3. Not a big difference. Our cosines are going to cancel out, and we're left with theta equals cosine inverse of 6 over 9. Now I'm going to double check what they want my answer in. They want it to the nearest degree. So that tells me my calculator needs to be in degree mode. And then we just go ahead and put cosine inverse of 6 over 9. And correct me if I'm wrong because I'm not over by my answer key. Was this 48 degrees?
Yeah.
Okay. That one is 48 degrees. So that's plenty of time to do the homework. If you don't get it done, that will be homework for tonight. Don't have homework. Just get what you can get done in 5 minutes. Tomorrow we're gonna have a really short lesson with more problems, but they're just the word problems of this. We'll have work time tomorrow. We'll have work time on Monday to finish all of these problems. So Monday's gonna be a work day. No homework due until Tuesday, and then Tuesday will be a review day. Wednesday is our test. Hanson.
I have one question.
Oh, yeah. Oh, okay. Okay. All right. So no homework tonight, unless you really want to do it, and you're really bored. You're just like, look.